In general relativity, from today, we are going to see a series of lectures on a very important concept, and this is the concept of gravitational waves. Definitely, you have heard and you have studied previously about these gravitational waves. Actually, the idea of gravitational waves is a very recent idea, although it was predicted or postulated by Einstein when he has given his general theory of relativity. In fact, first of all, Einstein postulated the existence of gravitational waves in 1916 just as a consequence of his theory of general relativity. But no direct detection of such waves has been made yet. So this is a vital subject for research, okay? Because at present, when the physicists are trying to know about more and more about our universe, then they look into the idea of gravitational waves, because this gravitational waves opens the window to through which we can look something new in the idea of a fabric of space-time, or you can say universe. So this is a vital or hot field of research at present. So this series of lectures will be very important for the academic course and also for the researchers. Okay, although I will not talk about in very deep the different research subject regarding these gravitational waves, but my lectures will provide a basic or a basic concept on which you can build up your research work. Okay, so this series of lecture will be fruitful for both the students and the researchers and the university professors, okay, which have interest in the study of general relativity particularly. Okay, since this is our first lecture on this important subject, gravitational waves, which is just a consequence of general theory of relativity proposed by Einstein. So in this first lecture, we will provide only a brief introduction regarding these gravitational waves. We will see from where these gravitational waves come to the surface of the earth. It is dangerous for the people living on the surface of the earth or not. And also we will talk about why it is interesting for the study, or why it is very important for the study of astrophysics and particularly the cosmology. Okay, so this will be a very brief introduction regarding these gravitational waves. But after this brief introduction on gravitational waves, we will talk about the proper theory and the different aspects, its properties, its detection in very detail in our forthcoming lectures. Okay. In fact, as I have told you that the idea of gravitational waves were proposed by Einstein when he has given his general theory of relativity in 1916 or 1917. Almost 100 years ago, Einstein postulated the existence of gravitational waves just as a consequence of the general relativity. But as I have told you that till date, we have not detected these waves in a confirmed way directly, but there are very indirect confirmation or indirect detection of these gravitational waves at present time. Okay, so this becomes a very important field of research, and both for the academician and the person who has interest in the insight of cosmology and this universe. Okay. When we talk about the existence or evidence of this gravitational waves, in fact, it is seen that this is due to the work of two well-known scientists, Joseph Taylor and Russel Hulse. Actually, in 1993, these two scientists gave the evidence for the existence of these gravitational waves. In fact, both of these scientists observed in 1974, okay, the two neutron stars orbiting faster and faster around each other. Appears that this rotation or this rotational motion of the two binary neutron stars around each other is due to the loss of energy due to the neutron stars in the form of emitted gravitational waves. In fact, as you know, when a charged particle is orbiting, its motion is accelerated motion, and according to classical electrodynamics, a charged object in accelerated motion emits electromagnetic radiation or emits energy in the form of electromagnetic radiation. Just like that, Joseph Taylor and Russel Hulse observed that when we see the orbiting motion of a binary neutron star around each other, then it appears that there is a loss of energy in the form of emitted gravitational waves. And so, in this way, both of these Nobel laureates provided the existence of this gravitational waves. So you can say almost 85 years ago's prediction, both of these scientists provided the proof for its existence. Okay. In fact, the predicted rate of orbital acceleration caused by the gravitational radiation, according to general relativity, was verified observationally with high precision. Okay. In fact, when these gravitational waves reach to the Earth, the then they are much weaker than the corresponding electromagnetic waves. In other words, we can say that cosmic gravitational waves, it means the gravitational waves which comes to the surface of the Earth from very large distance from the cosmos. On arriving on Earth, these are much weaker than the corresponding electromagnetic waves. But why? Definitely you have a question in your mind. When the cosmic gravitational waves reach to the surface of the Earth, these are very weak in comparison to the electromagnetic waves. What is the reason behind this? In fact, the reason is that the strong gravitational waves are emitted by very massive compact sources undergoing very violent dynamics. Okay, very violent dynamics, and these waves come from very large distance. So, in course of its propagation, they lose energy. Okay, in the space, and therefore when it reaches to the surface of the Earth, its intensity becomes very small, and that's why its detection is not very easy, because if the intensity of the gravitational waves reaching to the surface of the earth is very high, then its detection will be easy. And it is also seen that if the source of the gravitational waves is of a smaller mass, it emits actually the waves of very small intensity, and so its detection is not possible. Since only those gravitational waves can be detected which is actually emitted from a very massive body, and such massive body are found at a distance very large from the surface of the earth. Okay, actually these kinds of sources are not very common, and so the corresponding gravitational waves come from large astronomical distances. Okay, on the other hand, the waves thus produced propagate essentially unscattered through space without being scattered or absorbed from the intervening matter. So you can say that these waves are harmless. When you say that the waves produced propagate essentially unscattered, it means it travels without making any harm. Okay, or without being scattered or absorbed. It means these waves are neither scattered nor absorbed by the intervening medium. Okay, and this is also the reason that its detection is not very easy. Okay, now we are going to see why are the gravitational waves interesting. In other words, we can say why we study gravitational waves. What is the advantage for the study of gravitational waves, or the study of gravitational waves gives what type of informations so that we need its study. We will see in this brief introduction here. In fact, detection of gravitational waves is important for two reasons. First of all, their detection is expected to open up a new window for the observational astronomy, since the information carried by gravitational waves is very different from that carried by electromagnetic waves. The information which is carried by gravitational waves, that is entirely different from the informations which is carried by electromagnetic waves. So definitely we have already an idea of the informations carried by electromagnetic waves for a very large time. But since the gravitational waves provide new informations, new ideas or new informations, so its study opens a window for the new discovery in physics. Okay, so this new window onto universe will complement our view of the cosmos and will help us. So what are the main aspects which will be opened for the physicist to go through it and give the new idea to the people of this world from the study of this gravitational waves? Let us see. First of all, these gravitational waves unveil the fabric of the space-time around the black holes. Around the black hole, what is the fabric of a space-time? You can know from the study of gravitational waves. So this is a vital importance of the study of gravitational waves. Okay. The next one is that it helps us to observe directly the formation of black holes. How the black holes are formed, you can know from the study of these gravitational waves. So in this regard, the study of gravitational waves is very important because it deals with the information regarding the formation of black holes. The next one is search for rapidly spinning neutron stars. From the study of these gravitational waves, we can search uh, what, which are the neutron stars which are rapidly spinning. It means it opens the window for the study of the rapidly spinning neutron stars. Okay. The next one is dig deep into the very early moments of the origin of the universe. You know, the early moment of the creation of universe is a mystery till now. There are several theories. uh, what happened when the universe was created in the very its beginning, there was no separation between space and time, and that is a very great mystery of physics. But the study of this gravitational waves actually opens the window for knowing what happened when the universe was created, in the what happened in the early moments when the universe was created. That can be known by the study of these gravitational waves. Okay. The another point which makes its study very important is to look at the very center of the galaxies where supermassive black holes weighing millions of solar masses are hidden. It means there are a large number of black holes, or you can say millions and millions of black holes, which are hidden, which are not known till date. But by the study of this gravitational wave, we can know about all those massive black holes. Okay. In fact, these are only a few of the great scientific discoveries that scientists will witness during the first decade of 21st century. Okay. Now, the second aspect which makes its study interesting is detecting gravitational waves is important for our understanding of the fundamental laws of physics. Okay. Actually, the proof that the gravitational waves exist will verify a fundamental, almost 100-year-old prediction of general relativity. Also, also by comparing the arrival times of light and gravitational waves, Einstein's prediction that light and gravitational waves travel at the same speed could be checked. You know, Einstein has postulated that gravitational waves and light travels at same speed, but there was no proof of this very important fact of the general relativity predicted by Einstein. But when we study gravitational waves, we can check that the speed of gravitational waves and that of the speed of light both are actually equal. Okay. Finally, we could verify that they have the polarization predicted by general relativity. The state of polarization of these waves, what Einstein has predicted for it, that can also be checked. Okay. So these are the important facts which makes its study very interesting, very important for the unveiling of, for opening the mysteries of our universe. Okay. So in this, after this brief introduction, you have definitely uh, an eagerness in your brain to know about this very important concept of gravitational waves. Okay. So as I have told you that in our forthcoming lecture, we will start to know about the proper theory of gravitational waves, and after the study of proper theory, we will see that from that very theory we can know the different properties of the gravitational waves, and will be the subject matter of our forthcoming lectures, which we will see later on. Okay, thank you very much.